starting 90 Mount Auburn Street. We have AutoCAD drawings, and I'm going to model it in Revit architecture. So we're going to start by bringing in, it's a grid-based building. That is, the elements are organized around the grid. The grid is a system of columns and slabs suspended from and spanning those columns. New project. I don't know why this always defaults to architectural. I don't know if that's something to construction. I don't know whether that's something we can change. So, first thing you want to do is to copy the drawings. Somewhere locally, so let's just copy to my documents. I'm going to rename and we're going to link the AutoCAD files, not import them. Let's start with the ground floor. I've seen these before, so Revit will place them and lock them in place. So we're going to start with, we'll need another copy of this because we have two drawings in the same place. So let's unpin the AutoCAD drawing and just move it to can't see elevation markers. There's one, there's the other. Okay, that'll be close enough for now. So the first thing I'm going to do is draw the grid lines. Let's draw two, and then we'll do the ones in between. There are a couple here, anomalies. We'll rename them, renumber them. Let's go across. Let's rename that A so the others. That would be C. Let's draw D. And this one will be C5 will remain. Having done that, it's the beginning of our model. We'll have to look at an elevation to determine the floor-to-floor height. We'll do that next, and then create those columns in the perimeter wall. So double-clicking on the south elevation marker brings you to an elevation view. You can see there's this geometry that's strewn about here. Vectorworks has a unique way of organizing geometry, and whereby views, in order to report correctly with respect geometry with respect to each other, all these views have to be aligned and updated, and if they're not, you will have some geometry that is misaligned or otherwise floating about in 3D space, so you get this kind of artifacting. But if I go back to the plan view, you can see that the plan drawings are here. So that's other stuff that's lying out there. So my south elevation. Now, so what I need to do is bring in an elevation drawing so that I can determine the floor-to-floor height. And it'd be good to set the elevation levels early on so that you don't have to worry about them later, and you can constrain the additional elements that you're modeling to from level to level. So the base and top constraints, you'll have the correct values in place for the elevation. So I'm going to, from the insert menu, look for the elevation drawing, or a section. Well, let's start with the exterior elevation. Now, I want to place these parallel to this work plane. So let's see what happens by default. Okay, that seemed to work. In other words, the drawing is really small. I think it needs to be scaled. I'll have to look at that AutoCAD and see what's amiss. I may be able to scale it right here if I can inspect the so it is 11.3 from floor to floor. Let's see what it actually is reporting from here to there. 1.5.5. So 11.3. 11 times 12 times 3 is 135 inches. Divided by 12, 17.5 inches. Yeah. 7 points. Forget it. I'm going to repeat this step with after correctly scaling a file in AutoCAD. Anyway, that's this is the process by which you would assuming we had a correctly scaled drawing, I could then take set my elevations, including the parapet here, and if I had a section through the building and I were modeling the basement, I could set those elevations as well.